Hi viewers, I am bringing the solution of this problem which I had chosen from the ICSE 10th Standard Mathematics 6th chapter exercise 6D. The problem is the sum S of n successive odd numbers starting from 3 is given by the relation S is equal to n into n plus 2. Determine n if the sum is 168. Here the sum is given by n into n plus 2. When a number is represented or a sequence of number is represented by some term here which is n, it should be either from the set of natural numbers or from the set of integers or from the real numbers and so on. It should be from some number system. So here when I want the number to be the successive odd number starting from 3. So I want 3, 7, 3, 5, 7, 9 and so on. Here the number has to be chosen from the number system. There is no number system to represent only these numbers. So we have to convert this n into some other form in which I should get these numbers. So now if I take n from the set of natural numbers, the set of natural numbers contains the numbers 1, 2, 3, 4, 5, 6 and so on. So the odd numbers are denoted by 2m minus 1 where m belongs to n from the set of natural numbers, and the even numbers are denoted by 2m where m belongs to n. Now m is clearly from the set of natural numbers. When we assign m as 1, then 2m minus 1 will going to be 2 into 1 minus 1. 2 into 1 is 2 minus 1, that is 1. When m is equal to 2, 2 into 2 minus 1, 2 into 2 is 4 minus 1 is 3. When m is equal to 3, 2 into 3 minus 1 will going to be 6 minus 1 which is 5 and so on. The next number will going to be 7, next to that 9, 11 and so on. So I am getting only the odd numbers. Similarly, you can check for even numbers also. When m is equal to 1, 2m will going to be 2 into 1 which is 2. When m is equal to 2, 2m will be 2 into 2 which is 4. When m is equal to 3, 2m is 2 into 3 which is 6 and so on. We will going to get the list of even numbers. So now this 2m minus 1 represent all odd numbers from the set of natural numbers. But in the problem, I just want the numbers starting from 3. These are the only numbers which I want. So let us re-alter this 2m minus 1 so as to start from 3. Let us take it as 2m plus 1 where m belongs to n. Now when m is equal to 1, 2m minus 1 is 2 into 1 plus 1, that is 2 plus 1, 3. When m is equal to 2, 2 into 2 plus 1 is 2 into 2 is 4 plus 1, 5. When m is equal to 3, 2 into 3 plus 1 is equal to 6 plus 1, 7 and so on. I will going to get all the odd numbers starting from 3. So now coming to the solution. Given S is equal to n into n plus 2. Now, if I take directly as n, it should be from the number system, and the least number system which we have is the set of natural numbers, which even include the even numbers. So I have to re-alter this n. So let us take it as n as 2m plus 1. Then s will be 2m plus 1 into 2m plus 1 for this n and plus 2. That is equal to 2m plus 1 into 2m plus 3. Now expand this terms. 2m into 2m plus 3 plus 1 into 2m plus 3. That is equal to 4m square plus 6m plus 2m plus 3. That is equal to 4m square plus 6m plus 2m is 8m plus 3. This is S in terms of m. Now again in the data they said that the sum is 168. Sum is equal to 168. Now take this sum in this expression. We will get it as 4m square plus 8m plus 3 is equal to 168. Here this is a positive number. If we take this to the left side, this positive sign will going to become the negative sign. So 4m square plus 8m plus 3 minus 168 is equal to 0. 4m square plus 8m minus 3 minus 168 is minus 165 is equal to 0. Now this is a quadratic equation. The general form of the quadratic equation in terms of m is given by am square plus bm plus c is equal to 0. Comparing these two equations, a is 4, b is 8, c is minus 165. And the solution of this quadratic equation is given by m is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. This is equal to, now substitute for the values of a, b and c in this equation. Minus b is 8 plus or minus square root of 8 square minus 4 into a is 4 into minus 165 whole divided by 2 into 4. That is equal to minus 8 plus or minus square root of 8 square is 64. If I take this negative sign outside, then minus into minus will going to be plus 4 into 4 into 165. You calculate it, it will going to be 2640 divided by 2 4s are 8. That is equal to minus 8 plus or minus square root of 64 plus 2640 will going to be 2704 divided by 8. That is equal to, now we have to find the square root of 2704. You can even do the factorization and find the square root, but you have still easier method in your 8th standard. If you had forgotten it, you can go back to your 8th standard and you can learn it again. It is the very easy method. You have to group two digits from the right hand side. So if I do that for 2704, the last two digits are 04 and 27. You have to group it from the right hand side. So now we have to divide this in such a way that find the square number which is less than this number. So that we will get it as 25, and that is the square of 5. So we have to take 5. So 5 into 5 is 25. Subtract 25 from 27. It will be 2. Now take this 5 here and add them. We are going to get it as 10. Now in the usual division, in the next step we will going to bring down the one number, single number. But in this method we have to bring these two numbers together. So now we have 204. We have to get this number in the next multiples. Now I should get a number here, so that if I multiply these two numbers, I should get 204. Now let us take 2. 2 into 2, 4. 2 into 0 is 0. 2 ones are 2. So 1 or 2 twos are 204. If we subtract, it will going to be 0. The remainder is 0. So now from this I can conclude that the square root of 2704 is 52. So now let us take that here. Minus 8 plus or minus 52 by 8. Now this, therefore m is equal to minus 8 plus 52 by 8, or minus 8 minus 52 by 8. That is equal to 44 by 8, or minus 60 by 8. If you simplify this, it will be 11 by 2, or minus 15 by 2. Negative number is not the possible answer. This is not possible. So m should be equal to 11 by 12. But we are not interested in m. We realtered the form of n and we want the value of n. Right? We took n as 2m plus 1. So now let us take n is equal to 2m plus 1 and substitute the value of m. So this will be 2 into 11 by 2 plus 1. This 2 in the numerator and 2 in the denominator will cancel out, and m is equal to 11 plus 1, that is equal to 12. So my required value of n is 12. You can verify this answer by taking 12 odd numbers starting from 3, and if you sum up them, you will going to get it as 168, which means that we have to add 12 terms starting from 3 to get 168 as the sum. So now let us have a relook at the problem. They had given the form of general form of the summation. It is of the form n into n plus 2. This n will take the value from the number system. So if I take 1, 2, 3, 4, then the sum will going to be wrong. So I have to realter the form of n. So I let n to be of the form 2m plus 1, so that I will get 3, 5, 7 and so on, all odd numbers. Then we have to realter the sum to get it in terms of m. Then in the problem they had given the sum. Substitute that sum in this equation. You will going to get a quadratic equation. This is the general form of the quadratic equation, and the solution is given by this. Substitute the values and you will going to get a square root number. Solve this by this method and you will going to get these two numbers. Split them. If you split them, it will be these two numbers. simplify them, neglect the negative value, then you will get the value of m. We are not interested in m, we want n. So take n, substitute for m, you will going to get n. You can verify this solution by taking the sum starting from 3, 5, 7 and so on. Totally 12 terms. The last term will going to be 25. If you sum up this, you will going to get it as 168. Thank you all for watching the video.